we talked about isomerism, and we stopped here. So today we are going to see how we can prepare different alkenes in a laboratory. And actually, this part, I can say it is the most important part in organic chemistry, and then the reactions, because this is synthesis. I'll say synthesize this from this. Okay? So this part, methods of preparation, you shouldn't dare to miss. Okay? Somebody wants to be admitted, or I think somebody has joined. Okay. Where is my pen? It is here. So alkenes, we agreed, we say that they are those organic compounds with a double bond as their functional group. Okay? As long as it's a hydrocarbon with a double bond as a functional group, then you qualify to be an alkene. Now there are different methods of preparing alkenes. Okay? And these methods, they are useful as far as synthesis questions are concerned. And you need to know all of them, because you don't know. You want to know which question is coming. You want to know that they are going to tell you synthesize this from this. So you need to know all of them. And you also need to know the necessary conditions and the reagents that are used in preparation of alkenes. Okay? So the first one is, let's see how we can prepare alkenes from alkyl halides. And we say that alkyl halides, it's an alkyl with a halogen. And this halogen can be a chloride, can be a bromide atom, or it can be an iodine or an iodide atom. So from these three, from these alkyl halides, we can prepare alkenes. And how do we do it? We react these halogen alkenes or alkyl halides with alcoholic alkaline solution. Okay? And there must be some heat. Okay? You must heat a halogenoalkene in presence of an alcohol and sodium hydroxide solution. You form your alkene. And this is an elimination reaction. Elimination in that you remove some atoms, you lose some atoms. Okay? And in this case, it is you lose the hydrogen atoms. Remember, initially you start with a saturated organic compound, which is the alkyl halide. But when this saturated organic compound loses the hydrogen atoms, then it forms unsaturated organic compound as a major product, which is our alkene of interest. Sorry for that. Oh, okay. So the conditions that are there, number one, you must heat. Heating is a must. Okay. And number two, you use an alcoholic alkali or an alcohol. Okay. An alcohol, it could be ethanol in this case, which is CH3, CH2, OH in presence of a base or an alkali. Now the alkali can be sodium hydroxide or potassium hydroxide. Now for the questions, they can write this ethanol. Some questions they might write as this. They write ET, okay, and then they write OH. Now if they write this is ethanol, okay, this is ethanol. And so if you are given this, you still use it the way it is. Or some questions they might give you this CH, then CH, ethanol, something like this, and then they stroke it with a salt, sodium ethoxide, CH2, CH2, then O, sodium, or they might put potassium. So even if they do this, or even if they give you this, or even when they give you this, it is all the same thing. That is alcoholic alkaline. Okay? And you should be in position to write the equation, and you also write the mechanism. Is that okay? So for instance, we might give you this CH, CH3, CH2, CH2, OH, sorry, Cl, not OH, Cl, Cl, not OH, CH2, Cl, Cl. So this is the chloroethane, and then this chloroethane, we can react it with our alcoholic alkali, which is CH3. So I might give you this CH2, CH2, OH, and I stroke it with the potassium, or it can be sodium hydroxide, and then I do some heating. So if I give you this, then you must get an alkene. This is an elimination reaction. You must get an alkene. Okay? Nomenclature, this is chloroethane. We can say ethyl chloride. It is still the same thing. Then this one is ethene. Is that okay? So even if it is this, I might give you this chlorocyclohexane, and there is a Cl here. And I do these same conditions. I bring these conditions here and I put them here. Okay? And then I say, write for us the product. The product is the same. It is this one. Oh, okay. It is this. And then with a double bond. So how do we name this? Yes, it is cyclohexane. Is that okay? Good. Now the next thing is, think about the mechanism. How are we going to write the mechanism? Let me first check, as if there's somebody. Let me write the equation here for you to be able to follow. Let me try to be quick. Oh. Okay. Let me try to be quick. So this is CH2, then Cl, and then you form, this is an alcoholic alkali, then in presence of an alkalis, this is H, and then you must do the heating. Okay, so we shall form our alkene. So this is basically our equation. This is a 2, and then double bond CH2. So from this equation, there is a 2 here. You must be able to suggest the possible mechanism, and the mechanism, it is step-by-step reaction that shows a path to which a chemical reaction is going to take place. It shows from this step you form this, from this you form this, from this you form this. And here the very first reaction that occur is your alcohol, okay? So I used methanol. Your alcohol is going to react with the alkalis, and in this case it is potassium hydroxide. So if the two react, they will form potassium methoxide, which is written as CH3, then O, then with a K. And then there must be a plus on potassium and a minus on this oxygen. Plus water. Plus water. Now, this potassium methoxide being a strong electrolyte, okay, then it will undergo complete dissociation, complete ionization, to give you CH3 O, then K with a plus here and a minus. So it will undergo complete dissociation to give you methoxide ions, okay, plus potassium ions. Now, this methoxide ion, this one, it is the one that is going to induce, it is the one that is going to eliminate the hydrogen from our alkyl halide to bring about elimination reaction for it to form an alkene. Now, let's write it. It is going to be CH. Now I can write a 2 here, and then I bring the hydrogen here. It is still the same thing, and a bond, and a C. I write CH2, and a Cl here. Okay. So our methoxide ions that have been formed, okay, they will come.
Teacher,
Yes.
teacher,
Share the screen.
I'm not sharing the screen. Let me try to keep what I've written so far. Oh, so it is still today's network. Now I can't share.
teacher,
Yes.
teacher. You're glitching and you stopped sharing the screen.
Yeah, let me share it now. Hmm. I hope you should be able to see. Yeah.
Teacher.
Yes.
And also, pardon, you were glitching.
Yeah, it is still on the slide I was writing. I'm going to pardon it. I hope this network should be friendly. It should be friendly, okay? So I discarded. Okay. So let me pardon the mechanism. And the mechanism we are reacting C, an alkyl halide, which is CH2, and then Cl, with an alkalis, maybe. Let me use ethanol this time around, CH3, CH2, okay, and then OH plus our potassium hydroxide. And now this potassium hydroxide it is our alkalis, okay. And now, and this alkalis is the one which is going to induce the formation of an electron-rich species, which is a nucleophile. And now the nucleophile, it is the one that is going to induce. It is the one that is going to eliminate the hydrogen atom from this, so that the chlorine also goes to form an alkene. So you must do the heating, okay, to form an alkene. So this is 2, and then CH2. Now the mechanism is simple. Your alcohol first, the alcohol, let me first moisten my hands to improve on the handwriting. Okay, that's it. So the alcohol reacts with the potassium hydroxide, Let's demarcate our board. So the alcohol CH3 CH2 OH reacts with. Now when you are writing in a paper, you must write with a clear handwriting, not this. The C should be a C, the H should be H, and the C must be equal, same height with a H. And the three, these figures, these ones, they should be subscript. Okay? Otherwise, if you write this in an exam, then I assure you, you might not get any marks. So if you write, then you form potassium ethoxide, which is CH3, then CH2, then O with potassium, a plus on potassium and a minus on oxygen, plus water, and water is a neutral molecule. So here we shall not mind about it. Now after this, what next? This one, the potassium ethoxide is a strong electrolyte. So being a strong electrolyte means it will undergo complete ionization or complete dissociation. Complete dissociation. Okay, this is O, this is potassium, and then this is our minus. It will dissociate to give you the ethoxide ions. Okay, the ethoxide ions, there is a 3 here, and then CH2, then O minus, okay, plus the potassium ions. But now this one, it just goes, it is not significant in this case, but the interest is this. Now this ethoxide ion, it is a nucleophile, it is electron rich. Nucleophiles are electron rich species, but electrophiles, they are electron deficient species. Now if we write our alkyl halide, let's try to write it. CH3. Okay, I want to spread it. Let me remove the 3. So I put a 2 here and I put 1 hydrogen here. Okay, so this is still the same thing. I've just shown it. I've just shown this hydrogen. So this is CH2. I can also put the Cl here. Now this molecule is going to be, because of differences in electronegativities between the Cl and this carbon atom, then this Cl is going to attract the bonding electrons between this carbon chloride bond towards to itself, and so it will make this carbon to be more electrophilic. Okay, and so the result is going to be distributed on this carbon hydrogen bond that will end up polarizing this carbon hydrogen bond, that will end up inducing this hydrogen to be more of an electrophile. And so if we have your nucleophile here, which is the ethoxide ions, okay, okay, now the ethoxide ions will come and donate these electrons to this hydrogen. Now don't exaggerate. You see how I'm drawing my arrows? You see, they must touch. From here it is touching, even where it is going, it is also touching. So from here it will take away this hydrogen, and so these electrons, okay, that are between this carbon and hydrogen, they will be taken away by this carbon and finally contribute them to this bond to form a pi bond. Okay, and so you end up forming, before you form, now when you donate them here to form that pi bond, now you see this carbon. Okay, the concept is one. Carbon must have at least, actually not at least, it must have 4 bonds. It cannot go beyond 4 bonds. Is that okay? So if you donate these electrons here, then it means this carbon will have 1, 2, 3, 4, 5, and that one is it cannot happen. So what happens also, the chloride atom, this one, it will take away the 2 electrons that make that chloride carbon bond, okay, and it is given out as a chloride ion. And so the result is you form CH, CH2 and CH2, which is our alkane. And like I told you the other time, in in organic chemistry, we are always interested in the major compound. Okay, but if you also want to show the other inorganic compound, then this Cl is going to combine with these potassium ions to give us the potassium chloride. Okay,